Brilliant. Thanks, Leslie, and good afternoon, everyone. So, as Leslie said, I got a bit more of an introduction than David. Perhaps slightly means I'm slightly less notorious, but probably some of you, nevertheless, do know me. I've turned up at a few STA meetings, and we've talked quite a lot about one particular subject over the last year or two, which is the waste incineration BREF and back conclusions, and how we're going to implement the back conclusions, obviously with a particular reference to the monitoring requirements, and for the topic of my talk, with particular reference to monitoring requirements around mercury. So if I could have the next slide, please. So I don't really know whether the waste incineration back conclusions themselves require very much introduction, but for anyone who's not aware, these are the mandatory standards which have to be implemented for existing plants by 2023, at the end of 2023, and for any new plants, which are ones that we've issued permits for after December 2019, they apply straight away. And although we've left Europe, the standards have been written into UK law, and it's business as usual for their implementation. And so one of the key requirements when it comes to monitoring for waste incinerators is that for mercury, continuous monitoring, so mercury CEMs, are required unless the plant is burning waste with a proven low and stable mercury content. And so the key date for existing plants is that they will need to be have therefore determined whether or not they are burning waste with a proven low and stable mercury content by the 3rd of December 2023, in order to determine, of course, whether or not they require CEMs. Now, if CEMs are deemed not to be required, then those plants will have a choice either to carry on doing 6-monthly periodic monitoring, as they will be doing at the moment, or otherwise they can move to long-term sampling, whereby the long-term sampling has a lower ELV that they have to comply with if they choose that option. Now, the BREF itself and the back conclusions are subject to a negotiation process, and the UK position as part of that negotiation process was that actually when it came to municipal waste incinerators, at least, we didn't really think that there was a strong enough justification for mercury CEMs due to the relatively low mercury content of UK municipal waste, and we've provided quite a lot of evidence to the process of that, which was provided to us by industry, and of course which we hold ourselves as part of the monitoring that operators are required to do and submit to us in terms of their emissions to air, the bottom ash from the plants, and also their air pollution control residues, and obviously from that you can effectively do a mass balance and back calculate the mercury content of the original waste that went into the plant. And so that was our negotiating position, and we were successful in negotiating a slight change to the first draft of the wording around the requirements for continuous mercury monitoring. So originally the wording was that CEMs would be required for plants unless they were burning waste with an intrinsically low and constant mercury content, and we were successful in changing that to a proven low and stable mercury content. So basically getting rid of intrinsic and substituting constant for stable, to give us a little bit more flexibility to actually look at what emissions plants were producing, and to apply continuous monitoring on more of a risk basis. So that was the easy bit, getting that flexibility. Now we come on to how we then are going to implement that in practice in the UK, and so therefore, how do we answer the question, or how do operators prove to us that they're burning waste with a low and stable mercury content? And the first part of the answer to that question is that we think that the best way to do it is to base it on their emissions to air and the mercury content of those. Given that we're talking here about a requirement which pertains to air, that's the medium that's being protected here, and so therefore it's logical to look at therefore what's being emitted, which of course will be a function of the original input content of mercury in the waste. Next slide, please. So we decided that we would produce a monitoring protocol, and the basic premise of this monitoring protocol was to demonstrate consistent emissions below a particular threshold. So remembering that the definition is low and stable, if you can demonstrate consistent emissions below a particular threshold, then you're demonstrating stability. And so first of all, we obviously our starting point here is as well is a lot of existing plants that are already doing and indeed have a wealth of monitoring data based on periodic sampling. So the first question was how many periodic samples should be required to demonstrate consistent performance below a particular threshold. And we decided that 3 years would seem reasonable. Which for waste incinerators, which do biannual monitoring, means 6 samples in a row would need to be below the threshold. But also considering, of course, new plants would have to put this into practice as well. So there's a provision within the protocol for those new plants to carry out accelerated testing. And so the next question comes, well, that's all very well for plants which are able to demonstrate straight away that they can achieve consistent performance below a particular threshold on the basis of 6 in a row samples. What about those which can't? Should we require them to fit Mercury CEMs straight away? And we decided, well, no, we shouldn't. We should give them some flexibility and allow them to make some tweaks, some changes, improvements to the abatement system before deciding whether Mercury CEMs are required. So that's another feature of the protocol. And then, of course, once the 6 in a row results have been achieved, either on the basis of historic performance for existing plants or accelerated testing for new plants, we need, of course, to ensure that their performance ongoing remains below the threshold. And so we decided that if there is an exceedance in inverted commas, so if there's a value above the threshold, which you'll see in a minute doesn't actually equate to a value above the ELV, that the operator will have to, of course, investigate why that is, do a further 2 periodic tests over a month, and if either of those, if both of those results are below the threshold, that's fine. They can carry on as they were. If either of those results are above, they have to generate 6 in a row, investigate, and generate 6 in a row results again. So far fairly straightforward, but then the $5 million question is what should the threshold actually be set at? Next slide, please. So this is where it got really tricky, and probably where we have most of the discussion as to actually what the threshold should be. So remember, we were looking for low and stable. We've already determined what stable means in terms of 6 in a row performance and ongoing performance below the threshold. What does low mean? Well, if we look at the BAT-AL for mercury when demonstrating compliance either using CEMs or periodic monitoring, then like most of the BAT-ALs, it's expressed as a range 5 to 20. And the BREF itself says that the bottom end of the BAT-AL range can be achieved when burning waste with a low and stable mercury content. So that gives us quite a big clue, something to hang our hat on as a starting point, which was to say, okay, well, if you can achieve consistent performance below 5 micrograms, so the bottom end of the BAT-AL range, then with an allowance for subtraction of monitoring uncertainty, then that would appear to be reasonable. We can say you're low on that basis. We then developed that position slightly further, given that we said we could subtract monitoring uncertainty, and of course that can vary. To try and take a slightly more consistent approach, we said, okay, we'll if we add on the maximum allowable uncertainty under EA guidance, which is 30%, then that gives us, when rounded, sorry, that should say to the nearest microgram, of 7 micrograms. But obviously then we will no longer allow subtraction of monitoring uncertainty. But then the discussion moved on to what should we do about and how should we cater for possible outliers that we get in due to periodic sampling, due to the fact that although overall we argue, industry argues, and we agree that the overall mercury levels in UK municipal waste are very low, nevertheless you will get some fluctuation due to the heterogeneous nature of that waste, and we need to take that into account somehow. Next slide, please. So at this point, we challenged the industry to provide us with a little bit more data and some arguments as to what they thought the threshold ought to be, given the possibility of outliers of plants which are, otherwise have very low mercury emissions overall. And they collated some additional data and presented it back to us across 70 incineration lines over, I can't remember, around about 38 plants, I think it was, over 3 years. So 404 individual periodic sampling results overall. And the average mercury concentration across all of those lines was 1.8 micrograms, so significantly below the bottom end of the BAT-AL range of 5. And then when you looked at the per line averages, only one line had an average above 5 micrograms. So again, further demonstration really in terms of mercury emissions already being very low from UK municipal plants. Now, at this point, I was just going through the slides again this morning, and I wish actually that I'd included the histogram which I put together, because I think it would have given a nice illustration. It's too late for that, unfortunately, but we did plot the data. And it was very much negatively skewed, as you might expect from the low average, and we attempted some statistical analysis on this. So we worked out the upper fence value of the data, so the upper quartile plus 1.5 times the interquartile range, and that told us that statistically speaking, at least, anything above 3.76 micrograms could be considered as an outlier. But actually, they didn't really help us that much because we're already saying, well, we're considering a threshold of 7, and this was about whether or not it should be any higher than that. And really, as a regulator, we had to be able to agree to something which would give a threshold which would exclude, if you like, moderate outliers, but of course not the more extreme outliers in terms of their values, which are probably more likely to be indicative of high mercury, genuine high mercury levels from that particular line. And so what we did is we did some further analysis of the data. And we did actually some fairly crude analysis, looking to see what would happen if we set the threshold at 7 versus 10 in terms of the average values for lines with individual results either between 7 and 10 or greater than 10. If those particular values, so either between 7 and 10 or above 10, were excluded as outliers. And when we did that, without trying to go into too much detail and probably confusing myself, it basically indicated that if we were to set the threshold at 10, it would still ensure that the plants with the highest overall average emissions were caught by the additional sampling requirements, and therefore would need to make improvements to get their values below the proposed threshold of 10 micrograms. And thereby we would be capturing the lines which were which had the highest mercury emissions, and doing our job as a result, if you like. Next slide, please. In terms of the protocol itself, this is where we're probably at a slight disadvantage, because I imagine most of you are probably squinting at the screens trying to read what's on the flow diagram on the right hand side. And this is where I'm wishing that perhaps I produced one in landscape format rather than portrait. But it doesn't matter too much if you can't read everything that's on the protocol, and hopefully many of you, at least if you're STA members, will have seen the final version of this anyway. I'll just talk you through it very briefly. So I've already mentioned some of the aspects of the protocol. So we have a starting point where for existing plants, they have to look at their last 6 results and ensure they're all below the threshold, which, as we've now established, we agreed to be 10 micrograms. And they then, assuming that's the case, then we agree that thus far they are demonstrating consistent performance below the 10 micrograms, and therefore that no mercury CEMs are required. If, however, they are either an existing plant which isn't able to present 6 results in a row below the threshold, or indeed they're a new plant which hasn't yet generated sufficient data to show that, then they are able to do accelerated testing of 2 tests per month until they've obtained their 6 consecutive results. Hopefully at that point, those 6 consecutive results will be below the threshold. If they're not, then we give them an opportunity. We give them 6 months to do some optimization and further tests, which hopefully, again, then would from the operator's perspective, will demonstrate that they are below they can achieve 6 results below the threshold. If they can't, at that point, they have to then fit mercury CEMs. So if we then go back to, but if we assume that a plant has managed to achieve consistent performance through that process, then there is an ongoing surveillance, if you like. So they are expected to do 6 monthly sampling as per the BREF requirements and the existing IED requirements. And as I mentioned earlier, if they do get an exceedance of the threshold as a result of one of those tests, they have to do 2 further tests. And assuming they're both okay, they go back to consistent performance again. If not, then they have to take a further 6 samples. Again, hopefully at that point they will be able to demonstrate consistent performance below the threshold once more. In the unlikely event, however, that they can't, we give them one last chance to do further optimization and achieve that 6 in a row results. Those 6 in a row results below the threshold, and otherwise, if that does turn out not to be possible, then they would have to fit mercury CEMs at that point. So just very quickly, a few things to note about the protocol. First of all, that the back conclusions require 3 consecutive measurements of at least 30 minutes each to EN 13211, and not all plants will have been sampling to those standards yet. So there may have to be some additional. We think there will be some additional testing required over and above the routine testing in order for plants to generate those 6 samples in a row by the compliance time. So as I alluded to earlier, as I mentioned earlier, plants need to agree with us that CEMs are not required by the 3rd December 2023. And additionally, we also expect plants to demonstrate to us that the results are representative of the expected waste types that they receive at the plant. And also, we expect them to not just monitor their emissions, results of emissions to air testing, but also to carry out ongoing waste acceptance checks to make sure, for example, when it comes to commercial waste, that they're not getting waste that's likely to have high levels of mercury in it in the first place, but also to monitor the results of mercury testing of both their bottom ash and their APC residues, again, to make sure that there are no significant mercury increases in the waste. Next slide, please. So finally then, just in the last few minutes, just to think a little bit about the effectiveness of the UK approach and some of the advantages and disadvantages in support of having a protocol and not just having a blanket requirement, for example, for all municipal waste incinerators to fit Mercury CEMs. I think the strongest argument, which we had very much in mind throughout this process, is that the way the protocol works, by setting a threshold which is quite considerably below the top end of the BAT-AL range, and whereby the top end of the BAT-AL range is generally what we will apply at UK plants in terms of an emission limit value. It does provide a strong incentive for operators to optimise their mercury abatement and therefore minimise emissions, which of course is the end goal, is the main end goal that we've all got in mind. I think I've mentioned several times about the large data set, which we both cited as part of the BREF negotiations and also called upon when determining the threshold in the protocol, which does demonstrate and gives us quite a good level of confidence around UK industry's argument that mercury content of UK municipal waste is actually very low. And of course, as a regulator, we do have a duty not to place undue burdens on our operators, and the protocol very much takes a risk-based approach, we think, to whether or not mercury CEMs are required, which in turn is in line with things like the European monitoring BREF, so the reference document on monitoring emissions. Monitoring of emissions to air and water from IED installations very much underlines a risk-based approach and also supports the use of periodic monitoring data to indicate when there's a problem and therefore where CEMs might actually be required. And also, I think it's worth noting that certainly in the UK, even if you are able to get better resolution of your mercury emissions and actually see them in a real-time basis, plants aren't currently equipped to actually deal with them. I understand that there are some plants in Germany, for example, that have bromine injection. I think it's probably counted or considered to an extent still an emerging technique, which are able to react to mercury peaks to some extent, but our plants aren't. So it wouldn't necessarily confer any benefit in that particular way. So overall, we think it's the right thing to do. There are some possible arguments against, though. One of which is that, of course, if you do have mercury CEMs and a real-time indication of your mercury emissions, then you're more likely to be able to detect, let's say, a particular problem industrial waste that's coming to your plant, which is high in mercury, and of course, from the point of view of fitting. Point of view of determining your annual emissions versus the pollution inventory, for example, then if you don't have mercury CEMs, then it's more of an approximation if you're just taking your annual flow and multiplying that by the average of your periodic emission results. But nevertheless, on balance, we think it's the right approach to take for now. But of course, we're going to be looking with interest to where plants are required to fit this, and particularly perhaps elsewhere in Europe where that might be more prevalent. We'll be looking at the evidence from that, and that'll help inform any future approaches that we need to take going forwards, and any revisions in our position on this should that prove to be necessary.